Hello and welcome everyone. This is feature importance and ADA boosting. In the last session, we have looked at OB and how we can use that OBs to uh, act as a validation or a unseen data in our assembly learnings. So we have come across decision trees where decision tree goes about a parent node and two set of subnodes. Such things we have looked at. In this feature importance, we have looked at assembly, which means combining multiple machine learning models to have a power in voting and then having to have a diversified output. So bagging, pasting, such things we have looked at. Bagging really jumbles the input data or test data to create more randomized data sets, while pasting has a way of having to cut short and go about it. So that's one thing. Next is feature importance, estimates how useful each feature was for making prediction. So we have looked at many different machine learning examples like house price prediction or MNIST dataset. Many times we have seen that certain features have higher importance. Like for example, even in our iris dataset, which we are going to see again. So petal length and petal width have higher importance. So that's one thing to note. So again, there is another technique also to have to play around with this. It's called permutation, which might come about somewhere later. Permutation importance also. But for now, let's understand feature importance. It tells how useful each feature is in making prediction. So with tree assemblies, we have this parameter right here, which gives us an importance of the parameter in making the prediction. 45%, 45%, and others are about 10%. So that's one thing. So feature importance is not casualty, it is highly important feature. It doesn't really make a sense, but it just says it is important in deciding, but actually it might also contain impurities on some situations, and it can act differently in certain scenarios. But for now, we are knowing that petal length and petal width are highly important in making predictions for iris dataset. Next is ADA boost or adaptive boosting. So in case of ADA boost, it is in simple terms. So let's say we have many machine learning models. There might be few machine learning models which might be a weak performers or have less accuracy. So such uh, models are closely examined, having to take their incorrect uh, results and then improve their weights and improve their performance and retrain next set of machine learning models, and this process continues to repeat. And at some point of time we also increase the weight of their voting value to have a better assembly output, right? So common weak learners is a decision stump, which means decision stump has only one split, either yes or no. In ADA boost, many simple learners can be combined to create a powerful model. That's what we are looking at. So in case of learning rate, it decides on how each learner has influence, while fewer learners may be needed in case of high learning rate. In case of lower learning rate, each learner has less influence. At the same time, usually more learners are needed. So it's a again kind of a uh, decision where you decide whether it's a overfitting or an underfitting pattern. Just stay in between both of these. Lower learning rate might also mean higher accuracies with training set, as you see here, and more time for training a machine learning model. And ADA usually has a sequence of steps which is not like a parallel randomized forest machine learning model. It is sequential, so all of these also needs to be taken into account with machine learning models performance. So yeah, that's those were few things, and here we have few comparisons on ADA and random forest, which I will leave it here in this same notebook, which can be referred later. So permutation importance is another impurity based feature importance is in having to decrease in having to play around or remove certain features and see how it affects the prediction accuracy. So those were few set of things that we had for today. If you found this video helpful and interesting, please do like, share and subscribe to my channel. Thank you.